Hello everyone. So today we are going to have complete understanding of condition variable in C++. So without wasting time, let us start. So what is condition variable? It is first of all used to block threads until a condition is met. That's it. So let us understand this with an example in the code itself. So I'll create a file conditionvr.cpp and let us write down a code where we are having some worker thread and we are also having a notifier thread which is going to notify when to stop the worker. That's a simple code. Hash include iostream. Then we would also need a mutex in thread. So hash include mutex thread. I would also be having some sleep conditions in my code. So I would say let us also add chrono. Maybe if it is not required, we'll remove it afterwards. Right. Using namespace std. So the first thing is I would require a mutex. So I'll create one mutex mtx. And I would also require a ready variable, just a boolean. And initially I'll keep it false. Now the first function that I would write is my worker. So will be void worker. It is going to perform some task. We'll write it down afterwards. Then I would also require void notifier, which is going to notify when the worker has to stop. Means when he can actually proceed and complete its work. So here what I would do is I would write a simple naive code that there will be a while condition and until my while ready does not become true, I'll do nothing. So it will just go on looping again and again until the ready is not true. And once it becomes true, this condition will fail. And then we will go on and print some output, say worker process completed. And here I would write down some condition where I want to make my ready variable as true. So I'll just say ready equals to true. Since we know that if you have seen my previous videos where I have explained complete about the mutex, so ready is somewhere lying in a critical section. So I should use a, a lock to maintain the synchronization. So what I'll do is I'll take a lock guard and inside this I'll pass on my lock, sorry, mutex. So I have passed on my mutex and then after taking the lock, I'll set my ready variable to true and then the function ends. That's simple. In my main function, I would be creating a thread T1 with worker and a thread T2 with notifier. Just to see the output, I would say let us add some delay in between these two threads. So this underscore thread sleep underscore for and chrono seconds. I'll take 5 seconds. And at the end, we just have to join T1 dot join and t2.join. Let us try to compile this in C++, condition VR. Okay, it compiled successfully. Now if I'll try to execute this, we'll wait for 5 seconds and it completed. So we can see the code is working absolutely fine. But there is one issue in this code. The problem with this code is that here we are using a while not ready. It means that until the ready is false, we are actually trying to check it again and again. And the CPU utilization will always be there, which will try to see when the ready is becoming true. When it becomes true, it will break the while loop and it will go on to the next statement. So it is a bad approach where we are actually using the CPU, but it is not actually useful. So what we can do here is we can use a condition variable to avoid these things. What I'll do is I'll just comment it out and I'll create a unique lock first, or we can first create a condition variable, condition variable cv. Now with this condition variable, we would also require a unique lock. So with this unique lock, I'll pass on the mutex. We have lock mtx. Now this has gone into critical section. Once I acquire the lock, the next thing that I would like to do is the condition variable cv.wait. We have to pass a lock and a predicate. Predicate is something like a condition. Until my condition is not true, it will wait. So I'll just return ready. So until my ready is not true, it will wait here and then it will move on to the next condition. But we would also have to add something else. The first time when the worker runs, it will wait here. It will check the condition. Since it is false, so the thread will go into sleep. It will not be running now. So the CPU utilization will not be there. So it will go into sleep. Now to wake it up, you have to notify. And since we have a notifier function which sets a ready variable to true, so after setting it to true, I would like to call cv.notify1. When I call notify1, it will notify the other thread and then it will move forward. So let us try to compile this and then we'll see the working of the condition variable as well. Okay, we got an error. We missed a semicolon over here. Let us compile it again. We have some more error. The spelling mistake over here. It should be mutex. And we would also have to include a library for condition variable. Now let us try to compile this. Hopefully it should compile. Okay, it works. If I'll run this and we will wait for 5 seconds and it's there. So we see there is a difference in the coding practice. Both the codes were working absolutely fine, but we can see it is better to go with this approach because we can reduce the CPU utilization and it is much more safe. So let us see how does the condition variable works when we call cv.wait. You must be thinking that. Let us jump onto it. So when we call cv.wait, what happens is internally first it unlocks the mutex. We have passed the lock in the condition variable. So it will first of all unlock the mutex, then it will put the thread to sleep. since the condition is false, so it will put the thread to sleep. Then when the notify one or notify all, either of these two functions are called, then it will get notified. It will relock the mutex again and then move on to the next statement or into the critical section. So that is how it works. So you can see that it puts the thread to sleep, which reduces the CPU consumption. So what is the purpose of doing this is, first of all, there is a wastage of CPU resource. It has poor performance with the bad approach, and scalability issue is also there. But when we use condition variable, the thread goes to sleep, wakes only when it is notified, and zero CPU waste. So these are the advantages that we get when we use condition variable instead of our older approach. There is a difference in writing the wait condition for condition variable. We could have gone for a different way of writing. Let us move on to the code itself. The wait condition that I have written is using a lock and a predicate. I could have also written this in a different way, say while, and inside while I would write not ready, and inside this condition I would say cv.wait and pass the lock. The point here you should remember is that always use while, do not use if, because condition variable trying to make the thread wait while it is in sleep. But you should always remember that there is a problem of spurious wake up. It means the thread may wake up without notification as well, right? So if the thread wakes up without the notification, then if you have written an if condition, it might go false or true, and it can move on to the next statement either way. So to avoid this condition, if your wait condition was spuriously woke up without being notified, then it will again check the ready condition. Since it is false, so it will again go into CV wait and it will sleep again. So always use while to avoid any mistake. And both these statements are equivalent. We can use a while loop with the condition variable, or we can directly pass a lock and a predicate like a lambda function. So it is much more handy if you use the lambda function. So I'll just comment it and I'll uncomment this one. So let us move on to the next thing that I have already told you. There is a spurious wake up problem. A thread may wake up without notification as well. So if you just write cv.wait without any while loop, then your conditions might fail or your code might fail with some abnormal behavior. That is because it woke up and it was never notified. So the better approach is to have cv.wait, pass a lock and a predicate. In the same way, you can put this cv.wait and pass a lock and put completely inside a while loop. Both will work. Now, to notify a condition variable, we have two functions. One is notify one, and the second is the notify all. Notify one is used to notify a single thread, whereas notify all, if you have multiple threads going on and you have to notify n number of threads, then you can use notify all as well. Now, condition variable also allows us to have timed waits. It means you can put timeout as well. So let us see how we can use timeout. I'll just comment this one and I'll write another condition that cv.wait underscore for, and I'll pass a lock, comma, we have to pass the seconds or the time for which we have to wait. So chrono, seconds, and then I'll pass say 2 seconds. And then I have to pass a predicate as we were doing previously. So just return ready. So by this line, we mean that if the condition becomes true, then it will move on, or if condition does not get true within those 2 seconds, then also the timeout will happen and it will move on. So let us try to run this. So you can see we waited for 2 seconds, and since we got a timeout, so within just 2 seconds we moved on, and after that notifier must have notified after 5 seconds, means 3 seconds after we completed the worker. So this is how we can use timed wait as well. It can be useful in many ways in your production level code. Now we'll see one more thing. We have something called as condition variable any. Now there are certain restrictions over condition variable. Let us see those restrictions as well and how can we make use of it. So the condition variable has some restrictions. The first thing is that it works only with the unique lock. So you would require a unique lock. And I've already told you that we require a unique lock because unique lock can be unlocked after acquiring the lock. So unique lock can be used, whereas lock guard cannot be used with the condition variable. We cannot use timed mutex. We cannot use recursive mutex or any custom mutex type. Even the spin lock and third party mutex will not work. So keeping in mind these restrictions, we also have something called as condition variable any, which removes this restriction. So it provides you a more visible way than the condition variable. So let us see this with an example also. Condition var any. So again, we'll be writing some code, hash include iostream. Then we would also require a condition variable, include condition variable. We will require a mutex as well. And let us also have using namespace std. Now, instead of creating a basic mutex, I'll create a recursive mutex. Recursive mutex rmtx and a condition variable any, condition variable any, cv any, again a boolean ready variable. Let us keep it false. This time I have a worker, and inside this I'm going to use a unique lock, but this time the unique lock will be there with the recursive mutex. Lock and rmtx. So we have passed the recursive mutex into it. Now cv any dot wait, and here I can pass a lock. Along with that I have to pass a predicate. We have return ready. Now I'll again print out some log, worker thread complete, and let us copy the notifier code and the main from the previous code also. So we have the notifier code here and we have the main, but this time we are using cvne, so we can use cvne over here. Now let us try to compile this and see if we get any errors. Condition variable any. Okay, we got an error, thread T2, because we have not included the libraries. Also, let us include chrono. Now let us try to compile this. Okay, we have to pass our mtx over here. So let us also remove the mutex from the log card and replace it with recursive mutex. And now if I try to compile this, it compiled successfully. And if we execute this, we have to wait for 5 seconds and then it works. So now you can see it also works with recursive mutex as well. Ideally, condition variables are not able to support recursive mutex, but condition variable any provides you more flexibility without the restriction as well. So this is all about the condition variables. So you can practice this with more examples. We'll be coming up with more videos on multi-threading where we'll be using all these concepts while designing, and you will understand much more things from that. So thank you so much. Do like and subscribe the video. Thank you.